Okay, students. So, as per my words, we have already covered the various topics. So, introduction of AI, AI versus ML, and DL as well, and the problem formulation supported by the water jet problem example, and the production rules supported by the again the water jet problem, which is a famous and standard example. So, we have covered. When talk about the control strategy, so we have seen the introductory part of the control strategy, how we can control the our any model or any systems which is required to control to uh, provide the smoothness to our model as well. But after this point, we have a new topic that is required to understand the basics of the AI, that is a search strategy. To understand this topic, we have to understand the basics of the our searching mechanism. So, inspired from the search technique or search method in the graph theory and the data structure, as we seen into these two courses. So, inspired from these concepts, we have a search strategy. So, AI is what actually? AI is just our subject in the computer science. We have to learn that how machine can be intelligent. To a machine can intelligence. It means the machine means we're talking about the computing device. So computing device can be intelligent, but for that the computing device must be supported by the data structure. So data structure will be implement, or we can say it would be the implicit part of the our AI. So our basic should be clear before understanding the AI or any topic of the AI. From this point, we have seen, and I'm just going to part as a revise, just taking the idea of the search algorithm in the AI. One second over here, study we have also covered. Such algorithm, we have the two type of the flavor in the searching algorithm. One is uninformed, and other one is the informed. So uninformed means we are talking about the blind, and informed means we are talking about the everything will be into the guided pattern. So uninformed means unguided or blind. So whatever the information we are following, we can support those data or the information to get our uh, search the element or search the information whatever we have to search. Under this category, we have a breadth first search, a uniform search, cost search, depth first search, depth limiter search, iterative deepening depth first search, and bidirectional search. And so from this category, we will choose a limited kind of search because there are n number of searching algorithms, so we will not follow all the points. So based on our curriculum or syllabus, we will pick only the our important searching mechanisms, and we will take the example to understand the search topics. If I talk about the informed search, so we have a best first search and A star search. So A star search is very famous search algorithm. So from this point, we will try to understand some basic idea. And as a time permits, as a topic permits, so we will see the some topics separately, just like the best first search. So best first search we will see separately. So starting from the our search strategy. So what is mean by the search strategy? Search strategy means we are just trying to picking the order of the node expansion and how we can do. It is a just simple example. If we're talking about the any tree or any graph, we are cycle may applicable. So we try to search an element. So what is the path you are choosing? So while choosing the path, we are covering the we are following the some nodes. So as per the definition of the concept of the our traversing, as per the concept of traversing in the graph and tree, as we know, nodes should be visited once. If you try to revisit the nodes, so you are trying to increase the complexity or maybe the memory or size of the network or size of the graph. So it's a better idea to, as just you can see the last point, systematicity. I'm taking the first. That's saying to us, while following the search tree, the node should be visited at most once. You can visit twice, but you are necessarily increasing the memory. So try to avoid the increase the space or try to increase the avoid the increase the time. So time complexity is space complexity are the two major factor that is required to understand this strategy. So we have a five different points or dimensions that defines the how such strategy can be useful or which one could be useful. So completeness is what actually? Completeness is saying to us the solution we are following the tree, whatever we have, we are following from the uninformed and informed search. Is it possible to always find the good solution and that is exist or not? So if it is the solution that exists, is it good solution or not? So the completeness is saying to us, because there could be the n number of the possible solutions. Time complexity, space complexity, we know and we have already discussed. So I'm not taking much time to on this to do these 2 points. But one statement I can speak: the time complexity means the number of the nodes generated, and so definitely times is required. And the space complexity means the in the memory maximum number of the nodes or how many number of the nodes to be stored. And this can be found by the visited nodes. And optimality, definitely very, very important point or parameter or dimensions to understand the search strategy. And it's saying to us we need to choose a appropriate path which consisted by the least cost to inspire from the minimum spanning tree. So spanning tree we definitely we know what is the purpose of spanning tree. So it contained the we can say the least cost, and it also representing the all the nodes. So all the nodes must be visited once without any cycle. So that is the reason we have a spanning tree. And if talking about the spine tree, so a graph can have the n number of the spine tree. So we will choose the minimum cost based spanning tree, that is known as the minimum spine tree, that is also known as the MST. So these are the fundamental points we have to keep in mind while learning the basics of the our algorithms into the form of the category under the uninformed and informed search. So let us move to the first point. I would like to share something about the theoretical points. So the few points should be in your mind to understand the numerical example as well. So uninformed and blind search. As you can see, what is written? Everything is written. Just read the red color highlighted or just red color points. Uninformed search applies a way in which the search tree is searched without any information or guidance about the search space like the initial string, the operators and tests for the goal. So this is called the blind search because without any guidance we are trying to follow the our path. So that is the reason we have the our blind search. Here we will take very small example, but in a real life example it will take very good applications by which that defines the is it guided or it is not guided. So this, in this case we have a 5 different type of the our searching algorithm. So what are those? It is already seen into our image, but here also we can able to see or read some different type of the uninformed search algorithms. What are those? BFS and DFS, uniform cost search, that is also known in the shortened way UCS. Iterative deeping, depth first search and bidirectional search we will not touch because there is no need to understand here right now. But if curriculum or syllabus is permits us, definitely we will see. So we will focus on the above three important searching mechanisms. One is a breadth first search, uniform cause search, and depth first search. Now, let me explore more idea about the informed search. So, just focus on the red colored words. Informed search means we are talking about the guided search. It means the information we are following that will be guided pattern. It is just similar to kind of the two kind of the way we have. One is a guided pattern, another one is the unguided pattern. So unguided pattern we have into the uninformed search, and that is just not the blind search. We don't know. It is like similar to you need to go to the one place or you know which path you need to pick, but you must be damn sure at least you can do. So what you will do, you will start your journey. So after reaching the some point, after reaching the some intermediate point, so you will ask the local person, so what is the path I must use to cover the distance. So this is the way which is known as the unguided or uninformed. But if you talk about the inform, so from initial level, you know the direction where you have to move. And for doing this, the word we have to use that is known as the heuristic. So heuristic search is also known as the informed search, or we can say the informed search is also known as the heuristic search. First, I would like to tell something over here. The word is very interesting, and this is my favorite word, so I can speak something about this one. This heuristic word is coming from the heuristic. So I can write over here heuristic. This is a Greek word which means in the English to discover. to discover. So same example I'm taking, you have planned to visit some city. So you had a plan. It means what I mean to say that you have idea. You have following the proper path where I have to go, which route I must take, and where I have to stay. So this is known as the plan, and this is known as the informed search. It means you are following the guided pattern. So for applying or to learn the informed search, we have to follow the heuristic pattern or heuristic search, we can say. So heuristic is what actually? A heuristic is a way which might not always be guaranteed for the best solution we will get, but there are some possibilities. We are following, because of course we are following a journey, so there is no guarantee our journey will be success, but we have planned. So we can assure yourself, or we can assure ourselves that yeah, at least we can cover the distance without any hurdle, without any problem. But suddenly, after some time, so after the few days, we don't know what will happen, but we are expecting everything will be good. So same thing we can say, heuristic is just way and nothing. It is just way which might not provide the better or best solution always. There's no guarantee, but we are expecting we have a good probability. At least we will get the good solution in the reasonable time. That is the reason. So here the informed search means over here. Informed search can be more complex problem, definitely. So we have a greedy search and A star search algorithms are more important here to understand the informed search. So this is just the idea about the uninformed search and informed search. Now, these are the basics of these two definitions is clear right now. Tell me step by step. I will ask. The basics of these two terms are clear: uninformed and informed search. Because at the time of the interview, someone asks you a question, so you will be damn sure. So this is the meaning of the uninformed. This is the meaning of the informed search in the AI. Now, is it clear to all right now?
Yes, sir.
Yeah, good. Now, so this is just I'm just written some point over here from your second class or what we have seen. The
Excuse me, sir.
artificial is yes. Please tell me.
But sir, what are those information that is provided in the informed search?
Informed search, see, we are expecting we will follow this part to get the better solution. So our some idea will be initialized as a label. So we will follow this point. With the help of the example, we will see. Okay, so don't worry. We have some examples under the our different kind of the algorithms. So the searching mechanism. So definitely we will see.
Okay, sir.
Okay, so I'm taking a simple example. Suppose you are moving X city. You have never visited. So what you will do? Just tell me right now. I can give the answer from your examples. You tell me. First, what you will do?
Sir, I'll search for it. Like,
You will explore something about the city, route, and
yes.
restaurant, hotel. So that is what you are doing. You are trying to getting the information about your destination point. But suddenly, your boss or manager is telling you, just you have 1 minute, just go particular city. You don't have a time. So what you will do? You just ask yourself, okay, I'm going. On the way, I will ask from the various places or local persons. So I will go. So no one is guiding you, but you are following the guided pattern. So that is the inform. So this is a basic thing. So I'm talking about a general meaning here. That is the point you have to keep in mind. And with the help of the example, definitely we will see everything.
Yes, sir.
Okay.
Okay,
I
sir.
hope the point it is written over here, traveling assessment problem. I think in the fundamentals of AI and ML, the course you have already studied or just got the idea about the traveling assessment problem. What is this one? This is also known as the TSP problem. Have you heard this problem? This is a very interesting problem, and the fundamental of AI ML you have studied. I hope so. Is it?
Yes, sir, we have studied about it.
Okay. So can you explore this idea about the what is the TSP? That is a traveling assessment problem.
So we have to find a path which is of least cost to reach the destination, which takes the least cost to destination.
Hmm. See, this is the A, and this is the B, and this is a C, and this is the D. So A is connected C, and A is connected by D as well, and D is connected beta acting, and this is the we like this one. The story is telling to about the traveling salesman problem is simple, and a person who is a salesman who is traveling from one city to another city to sell the product. So he is just trying to cover the all the city. That is the point. Please keep in mind all the city with the least cost. So if I'm choosing this point A to C, I can go, or I can go uh, A to B directly, no issue. But I need to cover the all the distance, and C and D I can connect like this one. So with the help of the weight, or this can be also known as the distance, I can solve my problem. And this is the famous problem we definitely we have. So under this informed search, we have this point because here some information will be given. What is the kind of the information in terms of the weight and distance? So the student asked me the question here. You have our answer. Informed search means some information will be given in terms of the weight and distance. Is it clear right now? The basic idea is clear right now. Just tell me. Informed search means some weights and distance will be given. Okay, you have to go this point. Now clear?
Yes, sir.
Okay, good. Okay, so I was my point. I'm just picking once again all those points. So you have already gone through these points. So no need to discuss more over here. Just few points you have to keep in mind. What is the state space? What is the start state or initial state? We can say. What is the goal state, and what is the solutions we have? Possible solution we can say. What is the plan we have? So here we have one word that is plan. That part we have not discussed previously. So in the problem formulations, if you remember those words, we have seen the state space, the place where the our problem can be spanned. So and possible states or possible path we can find. And start state is our initial state where that could be the origin state. So from the point where we have to start our getting the solution. Now goal state, that is your goal test, and that is function that looks like the current state return the something to get there or achieve. And solution to the search problem is sequence of the action. So we have also used the word sequence and followed by the rules and regulation, and this actions is known as the plan that transform the start into the goal state. So this is the point we have to keep in mind. By the help of the plan actions and some rules, we can make our plan successful. So if you don't have any plan, you are just moving one place to another place, definitely you can achieve your goal, but there is no guarantee it will make you high cost. It is a simple example. You're facing any examination and you are not prepared about the such course, or you have not studied anything, so you will able to face the examination, but there's no guarantee you will write anything. You can write anything means you are not writing properly. Your answer is not justifiable toward the question as the question demanding. So that is the point. So you have to plan. Okay, after 2 days I have an examination, so I need 2 days for the preparation purpose. So let me go through the all the content of the my syllabus of this course. So this is what is the plan. Plan means the the idea, the thought that you need to transform your initial state to the last state of goal state as you have decided, and followed by the some rule and regulation. So this is a point. So plan can be achieved by the search algorithm. So the point we can this is the point that is written. That is reason I have written this statement. The plan we have that is required to use the search algorithm where I have to go. So this search algorithm really implemented into the many machines to choose the best path. Path means not always thinking about the journey, not thinking about the machine is moving from one point to another point. The searching algorithm or searching mechanism in the AI is telling to us there are the possible outcomes could be. So which outcome you are taking from the opting the certain rule and regulation followed by some actions. So what is the direction I'm getting with the minimum time, with the help of the least cost? That is the point. So do not think about the always we're talking about journey. Always there is a machine which is moving one point to another place. That is a path. That is not a specific application oriented concept. Searching means we can have the many outcomes, but which outcome you are picking based on your various dimension, as we have discussed the 5 dimensions: time complexity, space complexity, completeness. Okay, and systematicity. That these are the some points, and optimality, of course. So these are the reason I have written this statement once again over it from the problem formulation. Now, I have gone through the various sources, so I just got out the lots of the points. So I'm again writing the some points over here for the notes purpose. So you will not be worried about anything. So uniformed, we can say, uninformed search algorithm. It is also known as a blind search. So here I've just gone through the some points. So it is my responsibility to write some points over here. So what are those points? And that is our requirement to understand the searching algorithm as well, and because we will see all the tasks. Yeah, as I told you, we will see the depth first search, breadth first search, and uniform cost search. Okay, so if talk about the problems graph, so that contains in the static node S and goal node will be the G. So this is the point, just keep in mind. With the help of the these parameter we have example we will see. There will be graph which will be followed by the start node and goal node. Strategy. Strategy describe the manner in which the graph will be traversed to get the G. So from S to G we have to move. So what is the path I have to take? So based on the strategy could be the searching mechanism. Fringe. A fringe is basically telling to us this is a data structure kind function that used to store the all the possible current states, we can say, or nodes details that you can go from the current state. So initial state to last state, what are the nodes you are using, that will be stored to some point that is known as the fringe. Next is a tree. The result while traversing the goal node from the graph, every node will be traversed, just like example the minimum span tree. A graph can be transformed into the tree while traversing the all the nodes, and their tree cannot have a cycle. So definitely we have this point. So tree will be the example or output or result of the our traverse node. And now we have again words plan. Okay, so plan, this is defining the sequences or the sequences of the nodes from S to G. It means it is talking about the path. Plan means it is talking about the path. Okay. Same uninformed search algorithm we have. So we have the first depth first search. So let us move to the depth first search. Yes, tell me yes or no. Yes, it is clear to all right now. The uninformed search algorithm basics. Then can we start the first example, first search mechanism, depth first search? And you have any questions, so you can ask.
No doubt, sir.
Okay, good. So, what is the depth first search? As the name suggests, depth first search. So, in the depth first search algorithm for traversing or searching tree or graph data structure, this algorithm starts at the root node. Please keep in mind, just start at the root node and selecting some arbitrary nodes. These are also known as the intermediate nodes as well as a root node in the case of the graph, and explore as far as the possible along each branch with the node as well before backtracking. So backtracking will not allow over here. It means before starting the backtracking, all the nodes must be visited, and all the nodes, not all the nodes. There is no guarantee. All the nodes. It means possible all the nodes we can say, but from which direction you are moving you have to choose. So a route can have the left or right child. So if you're moving to the right child, so you have to go through that part. If you're moving to the right side, you have to go through that part. So that is the point, we have a depth first search. Yes. So depth first search, as the name suggests, I can write the some points, so please note down these points. As a name suggests, as the name suggests, DFS, a of the depth of the all all possible nodes. So all possible nodes must be visited. Okay, so we will focus on the depth. So the higher depth will be considered depth based or depth based node, we can say. Node will be considered. considered. Okay, so this is just idea, and now this is example. So let us understand this example first. And you have any question right now? So you can ask before explaining this example, and the basics of the DFS is clear right now. Just tell me. The basics of DFS is clear.
Yes.
Okay. So if I draw this example like this one, S is our starting node, that is the root node. S to D I can move, you can say, from the diagram, and S to A I can move. I'm just transforming this example, and A to B we can move. Yes, it is possible, and B to C we can also move, and C to G we can, and B to G. So V to G we can draw like this one. Yes, tell me, is it correct diagram? And C to G we can get, and S to D, and D to G. Yes, it is also possible. G will also be attached here. Yes, now clear right now.
Yes, sir.
I'm transform this diagram into this form, into tree form, so we can see. So the question we have: which solution would DFS find to move from S to G if run on the graph below, as you can see? Just tell me right now. Just I need your input. What your understanding over here? What would the solutions? Just possible paths. Just tell me.
Sir, S to D and to G.
As you have to keep in mind the points. The deepest node we will consider the first.
Oh,
So
yes, sir.
how we can
Then
identify the
S
depth? Yes, yes, tell me.
then S A B uh, C and G.
Okay. Yes. Any other student, please tell me right now. Answer is already hidden in the its concept or its definitive part. So we can say here, I can speak about this point. As a DFS traverse, as we have seen into the data structure as well, the tree deepest node will be considered first. So what is the deepest node? G. From the left side, you can say. So from S to A, I have to go, and A to B, I have to go, and B to C, and C to G. This is my path. So what is my definition? As you can observe before backtracking. So before backtracking, I have to use my path. I have to use my route. So just let me back to the once again. Yes, this one. Before backtracking, please understand this point. Before backtracking, I need to visit the possible nodes, and the nodes will be considered at the deepest node first. So which is the deepest node? Let me write over here. Yeah, this one. So this is my deepest node. Uh, this is my deepest node. So what would be my possible path? S to A I will come, and A to B I have to come. B to G I can go, but that is not deepest. So B to C I have to go, and C to G. So what would be my possible path? S to A, A to B, B to C, and C to G. Is it true? Is it clear to all right now how we are getting this point as per our theory portion and from the theory points? Is
Yes,
it
sir.
Yes, sir.
any problem here to understand?
No, sir.
Okay.
No, sir.
Okay, so let me share this solution. This solution. Just you, the people who told the answer correctly. So definitely we have this point. So from the blue arrow, you can see this is the path, and the path is already mentioned here as to A to B, B to C, and G. So if I give you this kind of question in the tutorial examination, I hope you will able to find the path. Is it possible? Are you able to find the path?
Yes, sir.
That's correct. So I will share some exercise on the tutorial. So please go through that part, and you have to just explore the idea. And one more thing, while writing the answer in the examination, write in detailed manner in the theory why you are choosing such path. So write your answer in the point basis and just show me the path properly. That is a more interesting point. And if talk about the here, we have some theory point. So I'm sharing the solution over here. So D is our depth of the search tree that is equal to the number of the levels of the search tree. So this is the fundamental points from the data structure and the analysis of the algorithm we have seen. N to the power I, that is the number of the nodes in the level I. So a tree can have the level, depth, and various points or left nodes and right nodes. So we have this one. And time complexity we can measure. So that would be the order of the n to the power t. That is the omega notation we are using. And space complexity, what we are getting from this DFS, that is the equivalent to the how large can be the fringe set. Fringe is what I've already spoken about the fringes. What is a fringe? Can anyone tell me right now? I told you what is a fringe. What is a fringe? I told you what is mean by the fringe. Just let me go once again to explore idea. Fringe means a data structure that is used to store the all the possible states. So if I'm talking about the fringe, so completeness is this space complexity. Space complexity can be used, can be measured by using the fringe. That is storing the all the nodes, possible nodes. So here, what are the nodes? S, A, B, C, G. So based on this parameter of a space complexity, we can measure. So that is the reason we have the use the word fringe. Now this clear right now from the space complexity. So if at the time of the interview or at the time of the viva someone asks you the question why fringe is required, you have a simple answer. The purpose of the fringe in the space in the search tree to measure the space complexity. That is the point. And completeness. So DFS is complete if the search tree is finite, and meaning if for a given finite search tree, DFS will come with a solution if it is exist. Optimality, DFS is not optimal. Yes, tell me yes or no. The statement which is written is true or not. DFS is not
Ye-
optimal.
Yes, sir, it's true.
Yes, tell me
Yes,
why. Yeah, tell me why you are telling it is true.
Sir, because the cost associated with finding is high because we have to reach till deepest point and we have to come back.
Super, it's a brilliant answer. Thank you, thank you. It's a great answer you told me, and this is the right answer. Because if talk about the deepest node we are looking at the first, so definitely cost will be high. This is the good point. Yeah. So it is already written over here, the cost spent is reaching very high. Definitely this is good. So this is a simple example of the DFS. This is the first our searching mechanism or algorithm we have seen under the uninformed uninformed searching, that is known as the blind search. Now it is clear all right now. Anyone who have any doubt? Is it clear to all right now?
yes, sir.
Okay, that's great. So after this point, we have a breadth-first search. So here, let us explore just theory point here, some points. Breadth-first search is an algorithm for traversing or searching a tree on the graph data structure as well. It starts at the tree root, undoubtedly, if you have to choose that, or some arbitrary nodes. Sometimes it is used as a search key and explore all the neighbor nodes at present depth prior to move on the nodes at the next depth level. Just can anyone tell me right now what is the sense of this one? Breadth first search. Just you have studied the BFS algorithm in the data
Sir,
structure from.
it explore the neighbor nodes rather than going to the deepest node.
Okay, to understand this concept, just let me once again draw the this example, same example I'm taking just by the BFS. We have to see this is our S, and this would be A undoubtedly, and from A to B we are moving, and B to C I'm taking, and C to G I'm also taking over here, and next one is B to G we have. So let me use this one, and this one would be D, and D to G we can take. Okay, okay. So this is the point. So from this example, can anyone tell me what would be the path form of the BFS algorithm we are applying? So what would the path?
Sir,
Yes, tell me.
SDG.
Yes, please tell me. Yeah, yeah. Yes. S
DG.
SDZ. So why SDZ?
Sir, because we need to find like not the deepest node, sir, but like the shortest.
Yeah, that is the point. That is the point. Yes, I'm getting your point. Your shortest one.
Yes, sir.
Yeah. So I'm just writing this point over here from your point. This is the shortest. Shortest first. And here I can write over here. See, this is the deepest first. Okay. So after understanding the example, we are getting the tricky points. What we have to do. Yeah, that is good. So as per the bid for searching telling to us, what is the point we have to keep in mind? So I'm writing here the points. Uh, we have to focus on shortest path. Shortest path. Okay. So only this is the simple meaning. So yes, anyone just can more explore, so I will be happy. Yes, tell me. There is a word I'm just remembering. So here I can write another point. This is the first point. Shortest in terms of the slowest actually. Slowest means the deep, little deepest. So this is the yeah, this is the point. Yeah, little deepest. Slowest node we will take as a first. So from this example, definitely uh, this G. So S to D we can take, and D to G we can see. So our path will be S to D and D to G. So what we are doing in this case, BF traverse the tree shallowest node first, and it would always pick the shallower, or that is a little deepest part branch until it reaches the solution. And just can you tell me right now, is it applicable? Is it true or not? We are going to the right direction. Is it right path?
No, sir.
Yeah, we can take. See, okay, I can sort out the problem. See, what are the possible path? Okay, first path I'm writing S to A, and A to B, and B to C, and B to G. Oh, sorry, C to G. Can we take this path? Can we take this path?
No,
This,
sir.
this is deepest, so we can't. We can take. And our starting node we have the S, and our goal node we have a G. So this is a good path we are having. This is the deepest, and it will contain the high cost. That is a we are not taking. This is a drawback we can say, and that is applicable only for the DFS, but not the BFS. So we will not consider this one. Second path I can take S to A, and A to B, and B to G. I can take this path. Can I take this path? Is a again path. Third path is S to D and D to G. So as per the definitions, what is saying to us, this is a path and this is another path. If I compare these two paths, this path is just known as the shortest path. So our solution would be undoubtedly this one. Now this is the problem, sir. Now it is clear. With help of this example, it is clear. Why we have a
Yes.
three paths. Why I'm taking in this path S to D and G, because we have a starting node and a goal node, and intermediate node doesn't mean. But at least we are following the shortest path. So ultimately we are reaching to our goal node by the shortest path. So S to D and G. You have a very chance you can place. You can go one point to another point by the various routes, but you will try to choose the shortest path to cover your distance to save your time. So this is the reason I'm sharing my solution over here. Once again over here, just look at this solution, and everything is written over here for your notes purpose, so you can go through that part. So definitely S is the depth of the solutions, and that is a little deepest, we can say. And into the power I would be the number of the nodes in the label I, and same we have the all the things, time complexity, space complexity. And compared to the DFS, BFS is optimal as long the cost of the all the ages are equals. So definitely it would be the optimal compared to the DFS. Is it true?
Yes, sir.
And so this is the point. So if in the examination, if I have the question, just differentiate the BFS and DFS. So are you able to write something?
Yes, sir.
Yes, sir.
Okay, so good. So let me move to the back slides once again. So from this point, what we have covered the DFS, and next one we have covered the waitful search. Now it's time to discuss with the uniform cost search, that is a UCS. Let us move to the UCS, or you have any doubt in the DFS and BFS, you can ask. Is it clear to all right now, these two terms, DFS and BFS? So we move to the UCS, uniform cost search. Yes, tell me.
It's clear, sir.
Okay, good. Uniform cost search, that is the third one under uninformed search mechanism. UCS is different from the BFS and DFS because here the cost come into the our mind. We have to think about the cost. As you know, a graph will supported by the weight and distance. We have seen the graph theory. So here, idea will be taken from the graph theory to have the weight and cost distance. We have to take this idea. So that is a play important role here to measure the cost as well. In other words, traversing by the different ages might not have the same cost, and the goal is to find the path where the cumulative sum of the cost is the least. So cost of the node, we can use the cumulative cost of all the nodes from the root, and root cost will be definitely zero because this was our initial point, and this will definitely be initial point, so the cost will be zero, of course. So this is the point you have to keep in mind right now to understand this concept. The cost node means we're talking about the cumulative cost of the all the nodes from the root. So what is the path we have taken from the root to goal node? So the cumulative cost we have to keep in mind. Let us understand this thing by the help of the example. Yes. Can anyone tell me this example? Are you able to solve this problem? The weights or the distances are mentioned over here. Okay, what I will do, I will design the graph and the simple way. So you need to tell me the answer for your betterment. What I will do, let me design the same graph we have. So S to undoubtedly S to A, this would be, and A to B, and B to C, and C to G, and B to G we have. Yes, this one would be, and S to D, and D to G. For a betterment, I'm taking the different colors to define the its weight or
Sir,
cost,
I
we can
guess
say.
SVG.
Okay, I will ask first. Let me draw the example. So definitely you are on the right track, but think and tell me the justification. So as to A we have a one cost, and A to we have a three cost, and B to C we have a one, and C to G we have a one, and B to G we have, yes, B to G we have one, and A to D we have a five, and D to G we have one. From this point, the question we have, which would be the solution of the UCS to find the better solution from S to G. So S is our starting node. Yes. So with the help of the cost, tell me right now.
So that will be SABG.
Okay. Why? Just can you explain your idea so other student can listen properly?
So because for going from S to G will cost from this path will be 5, and from rest all other parts that will cost 6. So 5 will be minimum. So we'll take this as optimal cost.
Think about the cumulative cost. Okay. Think about the cumulative cost. Okay. So S2, what would be the path? S2,
So S to A,
S2A, good.
then A to B,
Okay, super.
then directly B to G.
V2G. So we have a cost. Fine, this is a good one. Okay, let me give you idea to the students who are just not able to get the point. So I'm taking the common points over here. Yeah, the path I'm taking. Okay, the path. First path we have S to A. Here we will not talk about the shallowest or deepest. Here we are writing the possible path. Okay, A to S to A to B, and B to C, and C to G. So here the cost will be 1 plus 3 plus 1 plus 1. Yes, what is the cost? I'm getting 6. Next, if talking about the S to A to B, and B to G. So the cost here would be 1 plus 3 plus 1, and it would be the 5. If talk about the third possible path, as we can get from the our search tree, so S to D and D to G, so the cost will be 5 plus 1, that would be the 6. So from this point, you can pick the this one. Why? Because it is having by the least cost. Why I'm taking the least cost? Can anyone tell me right now? Why I'm taking the least cost? There is reason. Yes, tell me. The student, you must keep in mind all the points. If you're choosing the least cost, of what is the reason? Yes, can anyone tell me?
To save time.
To save the time, and as per the our optimality principle or dimension, just I'm showing once again your this slide. Whatever we have discussed, everything is more important, and my slide belongs to the synchronization. So optimality is saying to us, we will find the least cost solution. Is it true? So we can say this would be the optimal path. Am I right? Whatever we have designed.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so you are getting my points. So this would be our path. So what would be our path? S to A to B, and B to G. So path will be S to A to B, and B to G, and here we have to write the cost. So cost will be 5. So this will be the solution. Is it clear right now? Yes, this is clear to all right now. The uniform cost search, is it clear?
Yes, sir.
Yes,
Okay,
sir.
super. Good. Okay. So these are solutions. So everything is mentioned over here. So, but we have already seen with our previous slide, so no need to discuss more. Okay. Time complexity, space complexity, we can get it from the so we have over there. So for notes purpose, I'm just giving all the data. Now come to the point. Advantages. Yes, this is a good point. Usage is complete only if states are finite, and there should be no loop with a zero weight. And UCS is optimal only if there is a no negative cost. That is the point. That's like advantage. And suppose we have a negative point cost, so definitely our optimality we cannot get it properly. And what are the disadvantages? Explore options in every direction. That is the point. Why it is saying to us? Well, because you have to find the all the possible paths. Yeah, this one. It is saying to us, uh, we measure we have to measure all possible path. That is the reason. So it will take much time. So computation cost will be high here. We can say here computation cost will be high. Computation cost will be high. That is the point. And if information on the no information on the goal location, so this would be the drawback. So it means no information available. We are choosing the such path, but on the path we are not getting the information due to some reason. So this could be drawback. But this is not a much useful drawback, we can say. But the first one is more important. We will need to take in mind, keep in mind the all the possible path while evaluating, while getting the unique cost, informed cost search mechanism. So definitely it will take much. So computation cost will be high compared to the BFS and TPS. So far we have discussed. And advantage I'm speaking here, it is written clearly, it is optimal, it is best one, but there is no negative cost. If you have a negative no, so definitely it will go into the drawback. So here we have some points. So what we have seen so far, we have seen the three important uninformed search mechanisms. One is the BFS, DFS, and UCS. So these three are clear. Yeah, these three searching mechanisms are clear to all. Or anyone who need to ask any questions, please you can ask.
Yes, sir.
Okay, so let us move to the next flavor of the our searching algorithm, that is informed search. Okay, so
Excuse me, sir.
yes, please tell me.
Sir, this uniform cost search comes under uninformed.
Yes, I told you. Just look at this point.
Sir, but means some information we have, right, regarding the cost of the paths.
The uninformed is saying to us that just you are not looking at the drawback. It is telling to us if we have n number of the parts, so we have to evaluate all the n number of the parts. So we have the information about this point, but which path I must take. So I have to evaluate all the path, I have to go through all the parts, so I have to explore all the paths. So it is clearly mentioned about it, explore the options in every direction. So that is the reason the competition cost will be high. The information will be given, I'm 100% agree with your points, but what is the point, the drawback we have to keep in mind, we have to explore all the possible paths. So the computation cost will be high. So this is the reason we are keeping this algorithm or into the uninformed, because nothing is clearly. It is just a simple example. Uh, I'm giving you a message. There is an examination today, but I'm not giving you the message which course you have to face. So you are preparing in mind. You have to face the any one of the examination, any one of the course, but you are studying the five different courses. So you have to keep in mind which course I have to face. So you are confused at the time. So that is the reason some information are missing. So this is the reason we have to explore all the paths, because we don't know which path is giving the least cost. So we have to evaluate. So this is the reason the cost, the computation cost will be high. So that is the reason we are putting this algorithm into the uninformed searching algorithm. That is the only reason. This drawbacks makes you this algorithm into the or coming putting into the uninformed search. That's the only reason. Now clear?
Yes, sir.
Okay. Now this is the good point. So I'm happy to just some students asking the questions. Good questions. Now come to the point and to the another flavor. So we have the informed search algorithm. As I already spoken about the inform, which means some guidance, some information will be given. But here, what kind of information will be given? As the name suggests, heuristic search. The informed search is also known as the heuristics. So the information we can obtain by something, and the information we have inform the heuristic. And what is the heuristic? Heuristics what come from the heuristic, which means to discover something. So that is the point you have to keep in mind in learning of this concept. I am just underlining this one, heuristic. This information, whatever the information we are looking for, our making the searching efficient way, we have a heuristic. So that is the reason the BFS DFS was not much successful searching algorithm, and A star and A tree graph or different kind of the A star algorithms are much popular in the AI. That is the only reason. So here we have some algorithm we will discuss one by one. First one is the greedy search. Next one is start tree search algorithm, and next one is the graph search. So search heuristics. What is the mean by the search heuristics? Just keep in mind, in an uninformed search, a heuristic is a function, and this heuristic functions can be understood by the uh, GH and uh, gx and or we can say the hx. So hx means the heuristics function which will take some value, and with the help of the this heuristic function we will use the next heuristics functions next heuristic next current state's heuristic function value. So we have to use the g. So g and x are the two heuristic functions we will use to get the our path properly. So in the inform, so in the inform what we have here, just yeah, informed means, inform means a heuristic function will be used to get the information. That is the only meaning, and this function we can use in form of the g or h. That is a point. So that is used to estimate the how close a state is to the goal state. And for example, Manhattan distance, Euclidean distance, and these are the two distance algorithm, two distance concept in the mathematical we have seen the Manhattan distance, Euclidean distance, and we will also use the Manhattan distance and Euclidean distance equations or formula in the our machine learning algorithm, that is unsupervised learnings we will use to use in the KNN and K-means, and the supervised learning we use the K-means, so KNN algorithm. So where we will use what is the distance formula we have to use to find the neighboring nodes. So that part we will see also use. So these are the various famous standard, or we can say standard distance calculation or calculating distance functions or parameters. So that is the point. So that layers of the distance we have to use. Let's close to the our goal, and the different heuristics are used to different information algorithm. That is the discuss we will see in the next slide as well. So heuristic function we will use in form of the distance only. Okay, so what is distance? And distance how we can measure? What is the cost of the age? Distance means we're talking about the weight or cost of the age. So from the our graphs, definitely a graph can have the weight or the cost of the age. That can also be known as the distance, and that will be used. So let us start this point right now. Greedy search. So greedy search is the first searching algorithm inside our uninformed search, not uninformed, informed search, and that is also known as the heuristic search. So in the greedy search, we expand the node closest to the goal node, and the closeness is an estimated by the heuristic. So what is the parameter? What is the property you are using? That is a closeness. So in the exam time, I can ask the very different kind of the question in different way. What kind of the parameter we have to use in the greedy search? So you have to keep in mind the closeness. Okay, so closeness, closeness of the distance between between two states. Okay, two states or two nodes we can say, two states, two nodes. Okay, so this is the point. So heuristics is a defined in form of the hx, as I told you, estimate the distance of the node x from the goal node, and lower the value of the hx and closer to the node from the goal. So these are the key points we have to keep in mind while learning. Okay, so with help of the example, the picture, the idea will be more clear. And the strategy words we have seen, that is what is the plan, what is the thing you are looking to implement your grid research. So expand the nodes closest to the goal node, and expand the node with a lower h value. This h value means uh, this value we can write like this one. Okay, okay. Are you able to see this screen where the image where we have the graph and which contain the some values h9, h4, h2, h0. So this is what actually this is the heuristics values which is given. Yes, tell me right now. Is it visible to all right now?
Yes, sir.
Okay. So from this point, you can easily calculate. I'm pretty sure you can easily solve this problem by the my words. What would be the best path? Yes, think and tell me. You can take your time, 1 or 2 minutes, and tell me which path I must take to say this is the best path, or this is the best path for searching the our node. So yes, tell me. First, let me draw the uh, first let me draw this graph actually, so your idea will be more clear. Starting from the S. Okay, so S is our starting node, so I'm taking the S node, and S to A we have. So yes, I can take S to A, and A to B can go. Yes, undoubtedly, and B to C, we can, B to C we can go, and A to C we have. Yes, of course, A to C we can go, and S to D we have. Okay, S to D we have, and D to E we have. Yes, and E to G. Yes, of course, this is a good one, and C to G. So C to G, it means B to C we have, B to Z, and D to B. So D to B we have to add over here, and D to D, B and D. So E to C and B to E. So again, B to E I can write like this one, and this one could be okay, and C to G is already C to G. A to B, B to, yeah, this could be the C to G, and last one we have A to C. A to C already done. Okay, B to almost done. Yes, it is almost done. Oh, now tell me. Now it's your turn, and tell me what would be the path. Tell me, and what would be the path? Yes. Now you can speak. It's your turn to speak. Tell me which path I must take.
So STEG.
Mm, okay. Let me write here. According to you, SDEG. Okay.
Yes.
Okay, because we have only two paths here. If talk about the this point, we have a path. This is the, see. I'm just writing here for a betterment so you can understand. We have two paths that belong to the S to G directly. Okay, so this is the point. First path, S to A to B, and B to C, and C to G. Okay, if talk about the this path, so with the help of the is heuristic cost at the time, so what we have, S to A, what we have, S to A we have 9. Okay, so as an initial level, S is given 7. So if I try to add the 7 plus 9, something like this one I can do. So 7 plus 9, and so before starting this point, you can observe over here why I'm choosing the this A. So I'm not adding all the cost over here. As an initial level, I'm thinking about the this point. So as a greedy search algorithm is telling to us, if you're moving S to A, in which the heuristic cost we have given the 9. But if you look at the other point, S to G, S to D, so look at the this path. So what is the path? S to D and E and then G. So if I look at the other or least heuristic value, so here we have a 5. So I will move S to D, not the S to A. That is the point. So unlike this one, we can have the many paths, but we have to choose the initial level. What is the minimum value we have? So that is S to H. Now at the D, so D to B we can have. So here at the B node, what is the cost we have? That is the 4. Okay, and S to uh, D to E we have cost that is the 3. So I will choose this path. Okay, and E is connected G directly with the cost 0, undoubtedly 0 would be. So here I will choose this path. So my path would be S to D and E and G. This would be the my path. Now it is clear why I'm choosing this path. Yes, tell me. It is clear to all right now.
Yes, sir.
So as an
Yes,
initial level,
yes, sir.
see, that is the point. Do not think about this point. Suppose H will contain as an initial level 3. So what I have to choose? I have to choose S to A, then A to B and C, and I will check, and then I need to go. So do not think about the number of the nodes. Think about no, don't think about the cost. That cost part we have seen in the uniform cost searching algorithm. Here we are trying to use the heuristic function. So as initial level from S to A I move. So what is the heuristic value we have? So compared by the 9 and 5, so definitely I need to move to the D because it contains the least heuristic value. If it is contains the heuristic value, so my traversing cost will be minimum from S to D compared by the S to A. That is the reason. Now here I am sharing my solution. You can go to that part. Everything is mentioned over here. So the solution what I have spoken over here, that is a solution. Okay. So advantage is what? It works well with the informed search because what is the information is given heuristics value. Okay, here cost is not mentioned. Here heuristic cost is mentioned by the heuristic function. So, but the few steps are to reach the goal. Okay, so this is a good advantage. And disadvantage we can say can turn into the unguided DFS into the worst case. Yes, this can also possible, but this will drawback. So do not think about drawback. Think about always the advantage part for any kind of the thing in the AI. It's because now we are living in the era of the AI. So we will touch about the advantages part. That is a meaningful. So this is the good way we have covered the first point in the informed search algorithm, that is the greedy search. Now, is it clear right now? This algorithm, this example is very simple. I have explained over here. It is clear to all right now. Why I'm moving this path? Why I'm not moving to the other path? Based on the heuristics value which is already given. Yes, tell me right now.
Yes,
Is
sir,
it
it's
clear?
clear.
Okay, good. Now,
Yes.
Yes, sir.
okay, good. So A star tree search. This is very seems to be very complex, but it is very easy. From this point, you have to tell me the example so you can easily understand. This seems to us very simple, but it is not very simple. We have to add the two parameters. One is GX and other one is the HX. Okay. So A star tree search is simply known as the A search algorithm. That is a more important algorithm. I can write over here for your notes purpose. Uh, A search algorithm. This is very important for your examinations as well as your career as well. So star search algorithm that combines the strength of the uniform core search. Yes, I can underline the point. Uniform core search and greedy search. So what we will do? GX will be used for the cost from the uniform cost search. This will use the heuristic. Okay, so these are the two functions. One is measuring the cost, and another one is using the measuring the heuristic function. So value will be given. So by using these two values, we will get the one parameter. So HX is called the forward cost, and it is estimated the distance of the current node from the goal node, and GX is called the backward cost, and it is cumulative cost as we have seen in the uniform cost search. So here we are going to this one, and admissibility will be like this one. So this is the point we have to keep in mind. Okay, and to understand this problem I'm taking a simple example. Okay, then we will move the theory if it required. So let us understand the this point right now. So I'm just going to draw the tree, and then you have to tell me, think and tell me. Just the simple previous one example. So as we have as to A and A to B we can say, and B to C, and A to C we have, and C to G we can also add. This one we would be. I think previous one we have forgotten to add, but no issue. We can add over here. This one. C to G in the previous case. Let me add. Yeah, for your notes purpose. Yeah, this one. Yeah. So C to G and G, and then S to D, and D to E, and E to G, and D to B can go, and again B to C we can make like this one, and again we can make like this one. This is the possible parts. Now, what are the information is given? Let me write and think and tell me. So we have given all the cost. So A to S to A. So 3 is given. A to B is given the 5. B to C is given the 2. Okay, and A to C is already given 10, and C to G is given 4, and S to D is given the 2, and D to 4E, that is the 4, and E to G, which is given the 3, and D to B is given 1, and B to E, B to E, and this would be not C, this would be E. B to E we have 1, and B to C we have also, so I can add over here, that is given uh, 2, and here we have a G, that is given 4, and E to G we have given 3. So these are the cost and other things are given. Now heuristic function are given. So first tell me what is the step I must take. Just tell me what is the step I must take to solve this problem. Yes, I need your input. Yes, tell me what is the step I must take. Should I move to the A or D?
Sir, D.
D. Why?
Sir, because cost is also less and value of H is also less.
Okay, so that is a point. So I'm moving S to D. This is a good point. And now tell me now where I have to move. So B is containing the cost 4, and E is
D to
containing
B.
this is containing the cost 3. So tell me right now where I have to move.
Sir, which method should be prioritized, sir? UCS or A tree?
Now go to theory point. The following points should be noted with respect to the heuristic in A star Gx plus Hx. So you have to add. That is the addition you have to go through. Okay, now clear? So
Yes, sir. Yes, sir.
if I'm adding the 2 plus 5, so here would be 7. So I can move the D. Just look at this one. If I'm moving S2, so initially S contains the H, 7. Please keep in mind. S to D if I'm moving, so 7 plus 2 is cost, we will. So we will get the 9. S to A if I'm moving, so 7 plus 3, so it will be the 10. So that is the reason I'm moving to the D. Okay, so D is containing the 5. So 5 plus 1 I'm adding. So if I'm talking about the D to B, so that would be the 5 plus 1, that would be the 6. And if I'm talking about the D to E, so 5 plus 4. So what would be the my 9? So what would be the my next part? Yes, tell me right now.
B, sir.
Sir,
B to
We
B.
B.
are B, of course, B. So that is the point. Yes, good. So after reaching the B, I have the two options. B to okay, let me write here. Yeah, B to E I can cover by the 1 plus and E just having the 3 heuristic value, so that would be the 4, and or I can move B to G, so that would be the 2 plus and what is the cost of the G? Not C, sorry, C. C just having the 2. So that would be the 4. So here we have a tie. So tell me right now which direction I should move.
So B to E.
B to A. Why? Why? Just tell me.
So
It's the
because
answer.
the
Sir, how
Yes, tell
it's
me.
a
so
tie?
because the cost is less, and in comparison to that, that H value is also greater in this E part.
Yes, yes, that is the point. Tie is clear because B2E you are adding the way at cost, heuristic cost plus heuristic value of the E, that is a 3. So we are getting the 4 over here, and here I'm adding the cost 2 plus heuristic value, that is 2. So I'm getting the 4 again. So here we have a tie. So either you can move the E and C. So but the cost we have to keep in mind, the parameter, that is admissibility, that is again parameter. So with respect to that parameter, you have to choose which one. Which one you have to choose? Here we have a tie. So here the question is comes in our mind. H is greater than 0, x. This is the point. So tell me right now which path I must choose, E or C. Should I move to E or C?
So
Just tell
E.
me. E. So I can move E. And undoubtedly E to G I can move. So we have the last option. So no issue this one. So our path will be S to D, D to B, and B to E, and of course undoubtedly G will be. So this would be our final path, and that is a very simplest example. So in the examination, there is no guarantee, but it's a high probability I can ask some question based on the A star algorithm. I hope you can solve it in the examination. Is it clear to all right now?
So,
How you can? Yes,
sir,
yes. Tell me.
sir, when we are going B to C, sir, the addition should be, sir, 4 plus 2, right?
No, no. Why you are adding? Yeah, yeah, 4 plus 2, B2C, yeah, yes, that is the reason. Okay, I calculate. So 4 plus 2, so this will be 6. So we will not able to take this one. But when we are getting this value,
And sir, B to E is equal to 4 plus 1.
yeah, so 4 plus 1, yeah. B2E, 4 plus 1, uh, B2, yeah, okay, I have added 4 plus 1, so that would be 5. Okay, got it, got it. Just this, good. Okay, good. Good. You are on the, for rectifying this value. Thank you. Okay, actually, I have added the different values because from the graph I have noted down the wrong values, but okay, it's good. So, undoubtedly, so B2 will be our path. So, definitely this one. Okay. But when we are getting the tie, this kind of the value, so we have to think about the admissibility. Look at this one. Okay, so when getting any kind of type value or different thing, so please keep in mind about the admissibility parameter. Yes, please thank you for rectifying this value. So we have to choose the B2 only. So this is only the point. Yes, good. Yes, this is the good points I'm observing. Actually, what I have done, I just note down the wrong values from this parameter from the B. Yeah, now it is on the right point. Yeah. I have noted down the its upper weight, which is mentioned on the D, between the D to B. So that was yes,
Yes, yes, sir.
that is the reason only. No issue. Rest of the part is okay. So it this would be definitely pass. So we got the correct path. Now it is okay. So S to D, B, E, and G would be the our path. It is clear right now.
Yes, sir.
So what
Yes,
is
sir.
what is the thing we are getting? We are using the gx plus hx to get the our final value. So that's it. Same these things we have done here with the solution. I have here the solution. So the cost will be the 7 over here. So you can measure the cost. So how we can find the cost? S to D we are covering 2, D to B we are covering 1, and B to E we are covering 1, and here ultimately E to G we are getting the 3. So total cost we are getting the 7. Okay, so this is the cost we are getting. Now this is our solution. I have explained over here. So same cost we are getting. Okay, so this is our simple solution, and this is just idea about the A star algorithm, and this is the most important algorithm. Please keep in mind. Yes, round number 1115. Yes, you have any question? Just tell me. Yes.